By the way, you guys enjoying the 30-degree temperature change? This is crazy. A few days ago, it was 100 something. Anyway, all right. Bust out my jeans. I love it. All right. Get over there. So I think we left off last time doing some long division of polynomials, which really sounds exciting. So let's do a problem, long division, and then I'm going to show you the same problem with a shortcut. Okay. The shortcut is silly powerful. It's really crazy good, but it only works in certain situations, which is part of the reason why it's so powerful. So let's do this. Let's do what do you got, Jeff? I don't know. Let's make this, no, screw it, I'm not going to mess with that. No, this will work, yeah. Let's make this 2x cubed plus 4x squared minus x plus 7 divided by x minus 2. Let's see how gross that's going to come out. Let me think ahead a little bit. That's going to get a little gross. Ooh, that would be weird. No, let's not do that. Okay, we'll just do this. It's not going to be too bad. So let's set up the long division. Go ahead and set up the long division. If you weren't here last time, oh shit, watch that video. Let me ask you a quick question. I kind of did this. Am I missing any terms? So how would you tell very quickly if you're missing any term? Yeah, if I go 3, 1, I'm missing a square. I would have to put a 0 there. You'd want to. You don't have to. But dear God, you want to. You want a little placeholder. Because what do we do in our number system if I have 107 things? Do I just do this and pray people understand? No, we have a symbol. We put a placeholder so people know there's nothing there. So I'll do an example like that here in a bit. All right, what's my first step here? Good. X times what is 2x cubed? The same exact step you do when you're doing long division of numbers. Why does that make sense? Because variables are just numbers. They have to act the same way numbers do, because that's all they are. So x times 2x squared is 2x cubed, so 2x squared times x is insanely enough 2x cubed. Of course it is. We made it, so. What's 2x squared times negative 2? Yes. So then I change the signs, and that's an easy place to make a mistake. So any shortcut we do, I want it to change the signs for me, so I don't have to remember. Does that make sense? We can kind of see what we want our shortcut. In fact, how important is it? Look at what I keep writing. I keep writing this shit. Doesn't that shit always cancel? So whatever shortcut we make, I don't want to have to write that shit. Because it's going to cancel. Who cares? And then I get 8x squared, and then I bring down the minus x. X times what is 8x squared? 8x, it's crazy. 8x times x is 8x squared. 8x times negative 2 is negative 16x. And then I change the signs. These cancel. Bring down the 7. Can we stop it? Now, if I give you a big-ass problem, this is not a very big, we're not done, by the way, but if I give you a big-ass problem, it's just the same process over and over and over. So, I mean, it's just more writing, correct? It's not harder, it's just more writing. The minute I know, find out what goes there, multiply, change signs, add. Find out what goes there, multiply, change signs. I just keep doing the same. Okay. But you all agree with me that there's just way too much writing with long division. This is not a very big problem, but look at how much we've already written. X times what is 15x? 15. That's crazy. 15 times x. 15 times negative 2. And then I change the signs. That dies like it's supposed to. What do I do with this? Yeah, plus 37 over x minus 2. It's the remainder term. We write it like a fraction like we always do. Okay, we stop for a minute. Okay, so. Damn it. We'll see if I can do this. So here's the shortcut. The most important things in this whole problem are the coefficients. You guys, what was the power of the top in the first place? The power of the thing on the top. And I'm dividing by a first power, right? So we know the answer is going to start at x squared. Because I have a cubic divided by an x, I'm going to get a highest power of x squared in the answer. Does that make sense? If this was an 8th power divided by x stuff, I should get a 7th power at the end, correct? So the most important thing out of all this work is just what the coefficients are. And where do the coefficients come from? Where did that 2 come from? This. Where did that 8 come from? These. Where did that 15 come from? These. Yes? Okay, I just want to point out, those are the only parts of this whole damn problem that are really important. The rest of it's just kind of like, this shit's going to cancel every damn time. So, I'm going to ignore the variables. That's the first thing we do. We sort of ignore the variables. And wouldn't it be nice, instead of leaving this as negative 2, wouldn't it be great to change the sign from the beginning? So that's a negative 2, I'm going to make it a plus 2. So that when I do this step, I don't have to, if that would have just been a plus 2, wouldn't that have been a plus 4 to begin with? I wouldn't have to remember to change the damn sign every time, yes? So I'm going to ignore the variables. I'm only going to track the coefficients, and I'm going to change the sign. So here's how you set it up. I don't like hockey, but I like this idea. I put the little, and another way to look at it is what makes this 0? What makes this 0? What makes this, what value? 2. So that's how you can figure out another way. But I always like this idea. I'm ignoring the x and I'm changing the sign. So if that would have been x plus 2, I would have made it negative 2. Because this is x minus 2. I'm going to put a little 2 in a penalty box. And then I'm just going to collect the coefficients, because that's all that really matters. So what are my coefficients of my numerator? 2, 4, negative 1, 7. So be really careful about negatives and all that kind of stuff. So do you guys agree? If I would have made this a 5, let me see if you guys are really with me. If I would have made this a 5, wouldn't this number have been a 5? It's just blindly whatever the shit, especially, and here's the first thing I'm going to notice about this method. It only really works directly if I have a linear slope 1 divisor. Let me see if I can say that in more jargon. It only works if the bottom has a coefficient of 1, power 1. And that's why it works so nicely, right? It's one reason why it works so nicely. So to get this started, I'm just going to bring the 2 down. So this row is going to be my answers. I'm going to get the coefficient of my answers, the coefficients of my answer. So at the bottom here, I better freaking get 2, 8, 15, 37. The coefficients of my answer, yes? So let me ask you this. When I put that 2 down there, how did it interact? And again, ignore the x, change the sign. Isn't it 2 times 2? And then we put the 4 there, yeah? So bring the 2 down. 2 times 2 is 4. Oh, that was weird. I'm lagging in real life. That's crazy. And then I add these. Isn't that exactly what we did here? 4 plus 4 is 8. 2 times 8 is 16. So now I just bring this down to get me started. Multiply, add. Multiply, add. 16 minus 1. 2 times 15. Add. Did I get all the same numbers? Of course I did. And look, 4 plus 4, 4 plus 4. Negative 1 plus 16, negative 1 plus 16. 7 plus 30, 7 plus 30. Do you guys see that? It picks out the most important thing. A lot less writing, correct? Can you imagine if I gave us more terms, if I made like 4th power and 5th power and 6th power, this would get stupid. This would just grow this way a little bit. Yeah, I just put a few numbers here. You guys see what I'm saying? I would just put a few more numbers. Whoop-de-doo. It wouldn't take up that much space on my paper, dear God. Let me stop for a minute. I really want you guys to understand the power. The power. Now it's just interpreting the answer. Whatever the power was at first, this is 1 power below. So it was a cubic. So this will be the coefficient of squared. Now keep going. 2x squared plus 8x plus 15. And then this last term is always the remainder. And of course we get the exact same answer that we got before. Crazy sauce. Okay, let's try another one. A little less dramatic. Everybody get that? I'm sorry. You guys all get that? Go away. Okay. So let's try one a little bit crazier. Yeah, 4x to the 5th. Oh, this could get exciting, everybody. Minus 3x to the 4th plus 2x squared minus x plus 1 divided by x plus 3. Oh, this could get really gross. That was creepy. Too bad. Does anyone notice anything about the polynomial up top that I have to be careful about?
There's no
Missing a term.
It's missing a term. So when I collect all the coefficients, the coefficient of the 5th power, 4th power, 3rd power, I have to put a 0 or else my answer is freaking wrong as shit. So synthetic works because it's assuming you're collecting all the coefficients exactly as they would be. If you don't do that, it's hardwired to assume you do, so you're going to get the wrong answer. So let me ask you first, who goes in the little penalty box over here? Good. Ignore the variable, change the sign. Because the variables don't matter. As long as I got this in order and I represent everybody, I just need to look at the numbers in front. That's what controlled everything we did. So I'm going to put a negative 3, and then what am I going to put here? 4, negative 3, 0, 2, negative 1, 1. And now, a bigger problem, but it almost doesn't add that much work. How hard is it to multiply and add? That's the easiest shit around. What gets me started? How do I get this started? Bring the 4 down. Oh boy, this is gonna get crazy. Everybody, hold on. And then how do I get what goes here?
4 times 73.
Yeah, multiply, add. Yes? Multiply. So bring it down. Multiply, add. Multiply. 45. Add. Oh boy, this is what you get when Jeff makes a problem out of nowhere. You guys all with me? Multiply. Good. Add. Yeah, 399. Add. Multiply.
1194, I think it is. 1194? Negative 1194?
Now listen, did we get kind of big numbers? Do we really give a shit? Do we really give a shit? I'm multiplying and adding, and you're going to be able to use your calculator, so who cares? Yes? More numbers just means a little more to write, who cares? Take a minute, don't say a word, write the answer. Oh, yeah. Okay. Yeah. Nah. Shoot. Three more. It's fine. It's fine, Jeff. You'll be alright. Alright, so let's see. What do we got here? What power I'm going to start off with?
4.
Yeah, because add a fifth divided by x, stretch out of a fourth power minus 13x cubed plus 45x squared minus 133x x plus 398 minus 1193 over x plus 3. Kick ass. Synthetic division. Had anybody used that before? Synthetic? Some of you guys? Okay. It's awesome. It's freaking awesome. It only works in certain situations. So if I gave you a problem like this, could you use synthetic division directly? Why not?
It's just square.
Not linear. I love it. Now you could divide by, oh, can you factor this? Careful, how do you factor? Sure, how do you factor it though? It's not x plus 1, x plus 1. It's not x minus 1, x minus 1. Does anyone know how to factor this?
X and then x plus 1.
Nope. If I do that, I get a middle term, yeah?
Yeah, x plus I.
There we go. You could synthetically divide by I and negative I. Do you want to do that? Screw that shit. I'm just going to do long division. But when I do long division, I better include what?
0.
0x4, 0x squared,
And 0.
0x. You want those, trust me. Okay. So let me have you do this. Okay, this is perfect. Here, you guys do this problem. So synthetically divide these. Just pick this up, Jeff. Put it right there. There you go, buddy. Can you all read that? Not too bad for me. Okay. There we go. Go back. Go back. Thank you. By the way, I'm going to get an iPad, I think, so I can connect wirelessly and I can walk around and write some shit. That would be awesome. I hate being stuck over here. So again, we're doing synthetic division, right? So if you're doing long division, no erase that crap. Do synthetic. All right, let me see. I'm going to catch up to you. Anybody getting anything slightly interesting?
You don't have to put the 0.
What do you mean? Oh, I'm not missing any terms. Is that what you mean? But in your answer, is anybody getting something interesting? And you're all like, I don't know, man. What do you call interesting? All right, let me catch up to you. You bet. So bring down the 1, and then yeah, 3 times 1 is 3. Add, multiply, add, multiply, add. What did I do? Let's see. 7 plus 34 minus 24. Oh, damn you, Jeff. I love you so much, Jeff. You're an awesome person. And then you get 12, negative 12. Okay, so here's why I didn't get what I wanted to do. Damn it. I love it. I meant to put a plus through there. So I'm going to do that real quick. If this would have been a plus 3. How did I do that? So I'll just do it real quick. Then that would have been a negative 3, yes? Are you running out of... You are. Aw, poor little dude. Alright, switch note. So real quick, these will all be the same. 1, negative 3, negative 7, 21, 14. You should probably go a little slower, Jeff. We'll be okay. Are you dying too? Oh my god, everybody's dead. Everybody's dead. Come here. Well, shit. What do I have left? Oh, you. Hey, come here. Put me in, coach. You got it. All right, now, this is what I wanted you to see. So, what about this is interesting? No remainder. So, what do I get here? What's the answer? Good. Now, let me go one step further. That's the answer, correct? If the question was divide those two things, that's the answer. Let me alter the question a little bit. Let me say this. How do I factor this? By the way, if I gave you this and I said factor this, which again, if I was a better teacher, I would have just done that. I would have just said, here, you guys factor this. And after a few minutes, I would have been like, you can't do that shit. So, if I said factor this, grouping doesn't do a damn thing for me. You guys see that? Look at many freaking terms. I can't do that shit. But, what did we just figure out? This factors like what? Let me see if you guys can tell me. This equals this, yes, times x plus 3. Of course it does. If this divided by this is this, then this times this is this. Okay. So synthetic division is a pretty powerful tool to factor stuff we can't otherwise factor. I think I said that last time, but I don't remember if we had a zero remainder example. And then look at this. Guys, could I factor this? No, damn it. I was hopeful for a second. I didn't think about it. Can't factor that. So let me take you back a second. Did we have problems like this problem here earlier? What did we do with this problem? What did we talk about? Anybody tell me anything? We're going to graph this. What can you tell immediately? Multiplicity. So I know what they're doing at each root. I can figure out the roots, negative 3, 0, and 5, 0. I know it's going to go turn it, bounce at negative 3 and go through at 5, right? All that kind of stuff. And behavior. What power would be the highest if I did multiply out? Fifth power, yes. Why were the intercepts, why were the x-intercepts so easy? Because it's already factored. So, if you multiply this out, does everybody agree it's going to be x to the fifth plus something x4 minus something x3, blah, 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 blah. Well, it's going to be this huge freaking thing. And then I'm going to say, find the intercepts, which means you have to factor it, correct? And before you learned long division, synthetic division, you had no way to do it. So I'm going to give you problems that aren't factored yet, that you must use synthetic division to factor them. So the next thing we're going to focus on is, okay, Jeff, if you just asked me to factor this, how would I know to divide by x plus 3? Where the hell did that come from? You gave it to us, man, because you knew it was going to work. We're not going to get that from you, are we? No, you're not, huh? So the next thing we're going to talk about is, how do I develop a list of potential things to try to divide by? So everybody with me? Does that make sense? So does everybody understand? If I just gave you this and it said factor this using synthetic division, what are you going to divide by? Why does x plus 3 work? How would you know that? Yes?
You told me yes last week, but it's you take a factor of 24.
Yes. So if I multiply this shit out, can anyone tell me the first term? You all already did. It would be x to the 5th. Does everybody see? If I did multiply it out, did I just say multiply it out? No, I just said if you did. Can anyone tell me what the last term will be?
Minus 15. No.
You might need a calculator. If we did x plus 3 squared, what's the last term if you squared that?
12.5. If you squared or cubed.
If I did x plus 3 squared,
Oh,
what's the last term?
9.
9. Yes?
Yes.
If I did x minus 5 cubed, what's the last term?
125.
125. Okay, I got you. Yeah, negative 125.
Negative.
So you get 9 times negative 125.
That's right up the first one.
Oh, I see. Okay.
Negative 11.25. Negative 11.25.
Oh, is that what you said?
Yeah.
I think it said point something. Okay. So the only things, if I'm assuming I want whole number parts, the only things that I could possibly use that would make sense are things that have factors of this. So let me give us an easier one to look at. What if I had, you can do it, Jeff. Sure. Am I going to try to synthetically divide that by 5? Because x minus 5 could never be like a factor I want to consider because I'm considering whole number kind of things. You guys kind of with me? Okay. Because there's too many things to consider if I open it up to more than that. My God. We are going to deal with fractional answers. Anyone tell me? Let me see. All right, we'll get there. We'll get there. So what should I try to divide by? Not x or plus 5 or x minus 5. X plus 4, x minus 4, right? So I can synthetically divide by 4, negative 4. What else? 3, 6, 2, 1, 12. There you go. Okay, so you can make a list of factors of the last dude, and that'll tell you what to try. And then what do? You synthetically divide by all of them until you get a 0 to show up at the end. Let me make sure you guys are really with me. So if I give you a problem like this and I say factor this, the very first thing you should try is grouping, dear God. And then you very quickly see grouping ain't going to do shit. You guys see that? I'm not even sure. I'll bet you $40 that this won't factor. Because I just made it about it. If that factors, that's a neat day right there. I'm pretty sure that don't factor. So let me do this. Let me make one that works. We'll kind of step through the idea, and then you'll see your motivation for what you want to figure out next. So let me do this off screen. Jeff, you could have had this prepared. Shut up. Okay. Nothing too crazy. Yeah, that's fine. How was school today? I sat there and watched my teachers do shit. Let's see. Oh, that's interesting. I didn't want for that to happen. That's too bad. Okay, let's see. That's neat. All right, let's try this one together. Let's see if Jeff made a good problem. So I want to factor this. Let me make sure I made a good problem. Let me see. 1, 0, 1, 1. Yeah, okay, I feel better. So our traditional methods of factoring will work. Can I find factors of 6 that add to be -7? There's -6 and -1. That sounds great. Why wouldn't I do that? That's bad. Why is that bad? It's a freaking cube. If that was a square, that would work all day. It's a freaking cube. Damn it. Can I group? No, it's only 3 terms. What the shit? This is really weird. So, what is my list? So, for example, I want to really make sure you understand. If I long divide by x minus 1, that's equivalent to synthetically dividing by 1. Is everybody with me? So when I say I'm going to divide by 1, I mean I'm dividing by x minus 1. Do you guys see that? Because I'm going to just say, I've already said it. I'm going to just say that. Because this is what I say, this is what I mean. So can somebody make, so I'll start. 1 would work, maybe. What else might work? 2, holy shit. 3. 6. That's half the list. Why is that only half the list? Plus or minus, yes, okay. So how many things might I have to try?
8.
If you're really unlucky, you might have to try all 8. And let me explain why. How many factors should there be if I factor it all the way out? How many pieces should there be? 3. There should be 3. Some of them might end up being complex. I don't know yet. You guys, semi with me? If I synthetically divide once and I get x squared plus 4x plus 2, that's freaking quadratic formula. That's freaking complex numbers. You guys with me? So it is possible that some of the answers could be complex. But this process will give me nice, rational, real answers. Yes? Do you understand? 6 is not a very big number, right? What if I put 60 there? How long would this list be? Super long! Jeff? You're like, you gonna do that? Yes, I am. But we are, so this is why this makes sense. Our next motivation, after we do this problem, our next motivation is there anything that I can look at that will decrease my stupid freaking list? Because that list will eventually include fractions. It can get stupid big, and you're like, I don't want to try all this shit, man. So the way I do it is I'll make problems where the processes I show you will actually help, and that will cut the list down. There's one thing that will cut the list in half immediately. Sometimes, not very often, but when it works, it's like the list is cut in half. That's awesome. Is everybody starting with me on what's happening? Not at all. Well, shit. All right. Where am I losing people? So when we did this, did it make sense that this could only come from like x plus or minus 1, x plus or minus 2, 3, 4, 6, 12, yes? Okay. So that's why the list is the way it is. Plus or minus because, I don't know, it could be x minus 1, could be x plus 1, I don't know. This list could get very long if this number was bigger, yes? Had more factors, I should say. Because it could get a really big ass prime number, that'd be awesome. So I want to develop methods that I could use that will tell me if I can just chop out some of those options so I have less work to do. Okay. So let's first try to get an answer for this. Huh? 3 works? Oh, -3 works. Did you say x plus 3?
No, well, yeah, it'd be -3 if
-3
you're
works? All right, let's check it. You guys take a minute and synthetically divide this by -3. Please don't forget we're missing a term, right? Okay. Oh, I could give you that handout. That would make sense. Where's that handout? Here, yeah. While you guys are doing that, I'm going to give you this. It's got long division, synthetic division on it. So I know you're in the middle of a problem I told you to do, but this just has an example of long division, example of synthetic division. This is the one we actually just did a minute ago. This side, don't worry about yet. Who to what? Don't worry about that side yet. Okay. All right, so what are you guys putting up here?
1,
0,
0.
-7, 6.
Good. Bring down the 1. Multiply. Add. Multiply. Add. Multiply. Add. Yay. Yes.
Is there ever, in like an equation where multiple numbers work?
Oh, yeah, hell yeah. I know there should be 3 numbers that work. They don't have to be whole number real. They don't have to be real numbers. But most of the problems you're going to get are going to have, most of them are going to have all the answers are going to be real. Some could be fractions. We're not there yet. Some of them are going to have complex numbers. So can somebody tell me what level I'm at right now? That answer is what's the highest degree on that answer? Squared. Couldn't that then be a quadratic that I can't factor, that I have to use quadratic formula, and I could get complex numbers? I love it. Now, let me just show you this. What do I have here right now? What does this mean? X squared minus 3x plus 2. Couldn't you factor that? All right, I just want to show you mechanically what will work. I could write that and factor it. In fact, that's completely beautiful. The minute you get to a squared, dear God, just write that shit and factor it. You don't have to use synthetic anymore. But I just want to show you a mechanic. If I then want to try 1, I could just keep going here. Never, the minute you get something that works, this is bullshit. I don't want to ever use this guy in this problem again because we've already broken him down to this. Never start over here if you get something that works. Does that make sense? Yes?
If it's a new equation, are you using factors of 2? Or is it still...
Another thing to consider is the minute I get something that works, now my options decrease. Could one of my options be 3 again? No. Could 6 work? No. So every time you get something that works, your list actually gets smaller. You might be decreasing options, yes. That's why if I get a problem like this, and I have a long-ass list of stuff, and I can't chop the list down, I pick something sort of in the middle. Just because that might happen if it works. And I'll show you another thing that might happen, but we're not quite there yet. So let me see. Bring the 1 down. 1 times 1 is 1. Add. Multiply. Add. So what does this relate to? What factor? X plus 3. What does this relate to? And what is this? Coolness. And by the way, again, if you wrote this is x squared minus 3x plus 2. When you factor that, of course, you get x minus 1, x minus 2. So this is how you factor this. And now you can tell me the x-intercepts. What are the x-intercepts? Negative 3, 0. 1, 0. 2, 0. I love it. Yes?
So I used positive 3, and then I got 0 at the end. But when I do that method unit for 1, I guess...
So wait, let me see. So you use positive 3?
Yeah. I got it for the first one. Yeah.
Like here, right here, like?
Yes. Yeah,
okay.
Exactly.
So let's see. It's not going to work. Let's see what happens. Oh, I see. Right here. Do you see how it's positive 6?
Oh shoot. Okay, yeah, never mind.
Yeah. You're good. I'm not picking on you. That's a really easy thing. Your brain will get hopeful, and it says, "Oh, it's a 6. Okay, go cancel." Oh no. Let me stop for a minute. All right. What time is it? Okay. So we have synthetic division exists. It's its own thing. You can use it in a lot of different ways. One thing it's used for is to factor things that our normal methods of factoring does not work for. We are talking about, can you make a list of possible things to try? The next level would be, dear God, how do I cut that list down? Because it can get really big sometimes. But the intermediate step is, where would fractional answers come from? Can there be fractional answers to these? Of course there can be. Okay, so let's look at an example here. Will there be fractional answers to this? Will there be 1, right? So I get 2 and negative 3 over 2, yeah. So I really want this to make nothing but sense. If I set x minus 2 to 0, which is what you guys did, I'm going to add 2. What's the coefficient of the x? 1. So if I divide by 1, it doesn't become a fraction. The minute there's a number in front, those are the numbers that could end up on the bottom. All right, let me make a more interesting one, and then I'll really analyze it. 3x minus 4, 5x plus 2. Let me just write like this. What are the x-intercepts? 4/3? Negative 2/5. Okay. Right, because you would subtract 2, divide by 5. Is that cool? So the numbers in front are the numbers that could end up on the bottom, and the numbers in the end are the numbers that could end up on the top. And we see that shit already. When I did this, the factors of this are the numbers that could end up on top, because the bottom would just be 1. So that's why we only considered whole numbers, because the first number is a frickin' 1. So how do I make... So let's multiply this shit out. Let's see, I get 15x squared minus 20 plus 6, so minus 14x minus 8. Okay. How would I make a list of... We know the answers. But how do I make a list of all the possible intercepts for this? Well, let's start off from what you know. Wouldn't the top be factors of this? We've already done that, right? So what would the top look like? Plus or minus 1, 2, 4, 8. Over. What could be on the bottom are any factors of this stupid thing. And what are the factors of 15? 1, 3, 5, 15. So what is the complete list of all the possible things that could have worked? 1 divided by 1, so you can divide everything by 1, yes? So it could be 1, 2, 4, 8, and then you have to divide everything by 3. 1/3, 2/3, 4/3, 8/3, and then you divide everything by 5. 1/5, 2/5, 4/5, blue fish, and then you divide everything by 15. I know I said fish, it was a joke. 2/15, 4/15, 8/15. You guys feel excited about that? Now, we already know the answer. Was 4/3 a possible answer? If you can decipher my chicken scratch. Was negative 2/5 a possible answer? Plus or minus 2/5? Yes, right? But any of these could have been an answer. Yeah? Now do you really start to understand? You're going to be totally in on the methods to decrease the damn list. Because how long is this list? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 times 2, because it's plus or minus. There are 32 things you would have to try. No! Right? Okay, I'm with you. So I really want everybody with me. We've talked about the problem where we can see the end behavior, we can see the intercepts if I factor. Okay. I have to factor it though. And I could potentially see polynomials that we don't know how to factor. So that's where the synthetic division comes in. But in order to use synthetic division, I have to know what to try to divide by. I don't want to just pick any damn number, because that would take me the rest of the time. I want a way to get a list of things to try. And then when I get a list, I'm like, oh my God, is there a way to cut that list size down, please? So let's talk about that next. I desperately want you to see we have a goal. I get this. Okay, I know my goal. What do I do to get to my goal? And every time we learn something new, we're like, oh, but then I get a big list. Oh, but then I get this. It kind of is motivation as to how to do something about that, to learn what to do about that. So, first step. Let me see if you guys are really with me on this. All right, now, see if you guys are really, really with me. Can somebody tell me, whatever x-intercepts this thing has, can anybody tell me what must be true about them? Besides, it's got to make this 0. Of course it does. That's the definition. If you plug, let me see, I don't know, that's maybe a little too broad of a question. What's true about every number in there? All the coefficients. They're all positive. Is there any way you could plug a positive value in and get 0 out? Can anyone tell me what is the smallest output possible for this function? With positive inputs, we say like that, or non-negative inputs. 0 is the smallest non-negative input I could put in. What do I get out? 11. So, let me say this again. If I make, and I picked a horrible last number. All right, look. I wasn't even thinking. Here, okay? There we go, that's much better. Okay. So when I go to make my list of possible numbers, they have to be factors of 1100. The nice thing is, I don't include positive. It's only the negatives, correct? You guys understand that? If I see no sign changes, that means no positive numbers could possibly work. Because all they're going to do is add to each other. It can never make 0, correct? I really want this to make nothing but sense. Does everybody see what I mean by sign changes? If I go from term to term, did the sign ever change? No. Okay. So, this one could have no positive real roots. That is impossible. It could only have negative real roots or complex roots. So what about this guy? Oh, by the way, before I get too far, for F, how many answers must there be? How many x-intercepts must there be? And you might get some repeats, correct? But the fundamental theorem of algebra, how many answers when I set that equal to 0?
3.
There's got to be 3. Some could repeat, but there must be 3 solutions, correct? Now let me see if we can go one step further. If I ever get complex answers in a problem like this, where would they come from? We talked about it earlier. What would I use to get complex answers out? Quadratic formula. How many complex answers would I always get if I use quadratic formula? 2. They always come in pairs, correct? So does anyone see, let me say this, make this statement. That function has to have one real root at least. Because it could have one real root and 2 imaginary, or all 3 are real. You guys see what I mean? So let me go one step further. So this function could have 3 or 1 negative real roots. Why did I go down by 2? Because if it isn't real, it's complex. And how many complex show up at a time? 2. Not a big deal. So if it was a 5th power, I would say it would have 5 or 3 or 1 negative real root. Okay. So what about this guy? Could this guy, G, could this guy have positive real roots? All day long. Now, let's investigate the negative. How do I investigate the negative? Well, I'm going to put a negative x in. Can anyone see what would happen here? Yeah, this will be negative. Because the cube will keep it negative. The square will kill the negative, correct? So I really want this to make sense. If I cube a negative, I get a negative answer, don't I? If I square a negative, I get a positive, correct? And we're assuming real numbers here, correct? So that sign won't change. So the sign will only change on the odd powers. How many sign changes do you see in this? None. So let me ask you this. If x were something like 2, could this ever equal 0? No. None of this would actually take away from each other. I need you, let me see if I can really make this make sense. If I made x 2, wouldn't this be negative minus something minus something minus something? Yes? Could that ever make 0? And again, it's the whole idea of, do I see any sign changes? No. So it seems to be that the number of positive or negative real roots is related to the number of sign changes I see. Okay. So in this situation, how many sign changes are there from the beginning? And I really want this to make sense. What is it right here? What's the sign of the coefficient? Does it change sign?
Yes.
Yes. Does it change sign?
Yes.
Yes. So there's 1, 2, 3 sign changes. So there could be 3 or 1 positive real root. Because again, if it's not real, it's complex, and they show up in pairs. How many sign changes do you see in g of negative x? None. So there are 0 negative real roots. Which means, again, when you go to make your list, you don't have to put plus or minus. You only have to consider the positive. Maybe. So this is what's called, in fact, real quick, does anyone know the official name for the XY plane? That's your XY plane, right? Coordinate system. Does anyone know the technical name for it? We give props to the dude who came up with it. Cartesian coordinate systems, because it was Rene Descartes. Supposedly was sick in bed. He was watching a fly move around in the ceiling. He's like, I could see where that fly is using X and Y coordinate. Did that happen? No idea. Would it make a good movie? No. So that's the urban legends of math. They're not a good movie. So Rene Descartes did this. So if you hate graphing, then just find Rene Descartes' grave and just yell at him or do whatever you need to. But we call this Descartes' rule of signs because he also did all this business up here. So look at that handout. The other side. Where have I put them all now? There it is. There's Descartes' rule of signs. There's some other stuff here we're going to talk about in a bit, but I just want to focus on Descartes' rule of signs. Let's do the first 2 steps of this problem here. Can you take a minute, list all the possible rational zeros? All the possible rational roots. Will there be any fractional real roots possible? What's the first coefficient? 1. So it would be a 1 on the bottom, so you're going to get nice whole numbers, right? So how do you develop this list? Help me out. How would you make the list? What would you look at? What number would you look at? 40, because that's going to be, that comes from all the numbers at the end, which would then be how I get the x-intercepts. If I see x minus 2, it's 2, right? So the n numbers are what determines the x-intercepts. So what are the possibilities there?
1, 2, 4, 5, 8, 10.
And real quick, this is just a side note. You don't have to memorize this. What's the square root of 40? Roughly. It's a little more than what? It's a little more than 36, so square root of 40 is a little more than 6. Do you all agree with me what I'm about to say? Let's see if you agree with me. There's some numbers I have to come up with, and the rest are easy as shit, because I can do 8 times 5, 10 times 4. So do you see how the turnaround point? The turnaround point is roughly the square root of this. So once I get to about 6, I can then turn my brain off and just go 8, 5, 10, 4, 22, 41. Do you see how there's a natural kind of like turnaround point where they start to pair up? If you don't like what I just said, it's not necessary. It's just a neat little thing. Yeah. Now look at P of X. How many sign changes do you see in P of X as you move? I think I heard it. Does everybody see 2 sign changes? So as you move, it's positive, still positive. Now there's 1, still negative. There's 2. So as you move, does the sign change from one term to the next? How many times? Twice. So how many positive real roots possible? How many sign changes do we see? 2. So there's 2 or 0. Does anyone remember what we did to investigate the negative real roots? Kind of makes sense what we did. Plug in negative x to investigate the negative real roots. So here's the shortcut. Let me see if you guys really get this. The shortcut to do p of negative x, where can I put it? I'll just put it here. All the odd power ones will change sign. All the even power will stay the same because a negative to an even is positive. It won't change the sign. I need that to make sense. So like, this will change signs, this won't. This will change signs, this won't. This will change signs. 40, don't give a shit. How many sign changes do I see now? 3. So there's going to be 3 or 1 negative real root. So did Descartes in this situation, did Descartes really help me? No. Descartes does not help very often, but when it does, it cuts the damn list in freaking half. That's why we take a moment, we just say, did Descartes help me? No. Okay, well, shit. The reason I wanted to do this kind of problem is, and I know, we've done a lot today. I know this. Everything we've done today has been going towards being able to factor the stupid polynomial so I can get the x-intercepts. Is everybody with me? Every single thing we've done today has been like, well, shit, Jeff's an asshole. He's going to give me a polynomial like that. I can't factor the damn thing. Synthetic. Oh, synthetic. Oh, but then what numbers do I use? Oh, shit. Okay. And then, there could be way too big of a list. Okay, can we cut it down? Descartes sometimes not really shit. So then there's one more level of something that will help us cut down the list size. Can everybody take a moment and just do what I ask on part C? And let's interpret what we get. Then I'll let you out of here as soon as we're done with that. By the way, tomorrow, just to let you know, we'll have the quiz, and then I'm going to have a handout for you guys to work on related to everything we've done today. All right, we'll just kind of focus on that tomorrow. Just to warn you, these answers could get kind of big. I can't remember. Do I have room for this? Not really. Too bad, Jeff. Yeah, okay. Barely. So let me show you a little trick. At this point, I'm hoping you all just eat synthetic division for lunch, right? Synthetic kicks so much ass. Multiply, add, multiply. Already, this is looking a little crazy, yes? What's that, 43? Yes. Times 8 is 344, I believe. And then that's 309. And this is 2400 something. Look what I'm doing. Positive, positive, positive. Okay. Do y'all agree with me? There's no way in hell this is going to work. Do y'all agree with me that when you do 142 plus 2400 something, you're going to get 2500 something times 8 is stupidly positive? Okay, so I know it's not going to come 0 at the end. So at that point, I don't give a shit what I'm getting. All I care about are the numbers. Now let me see if you guys are with me. Are there any sign changes in the answer we got?
No.
So that means, that is related to Descartes' rule of signs. What that means is, if I try to use any number bigger than 8, any positive number, it's got to be positive, any number bigger than 8, it will not work in here for pretty much the exact reason that Descartes' thing didn't work. So what we found here is called an upper bound. If I divide by a positive number and I get no sign changes in my answer, nothing above 8 will work. What does that mean? I can now throw some shit out of my list, yes? Be really careful when you do it. Don't just cross through these because the negatives still work, yeah? But then you do negative 8. Has anyone had a chance to do negative 8 yet? Okay. Do it. So now I'm using a negative input. Let's see if you guys are cool with what happens here. Oh shit, what is that? Oh, flub. Is that 206? No, 216? I think. Yes. Negative. Negative big. Positive big. Positive big. Negative big. Negative big. I know it's not going to work. So that I can just kind of follow. Does it change sign between every single one of these?
Yes.
Yes. So if I divide by a positive number and there are no sign changes, that is the biggest possible answer. Did 8 work? No. So therefore 8 doesn't work either, and nothing above 8 will either. If I divide by a negative number and I get nothing but sign changes, then that is a lower bound. Nothing below 8 will work. And in fact, negative 8 didn't work at all. So now I can do this to my list. Go away. Positive 8 and up won't work because 8 was an upper bound. Negative 8 and below won't work because negative 8 is a lower bound. So I just chopped my list in half by dividing by just 2 things. So if you combine Descartes' rule of signs with upper lower bounds as you do your work, the list gets really small. And I will design problems on a test where that will happen enough so you're not like wasting all time. Now let me try 1/7. Now let me try 3/4. I'm going to try to make it so as long as you interpret it correctly, your list should decrease in size. Because otherwise it's just busy work. Oh my God. So next time we'll finish this one, and then I've got another handout, like I said. So that's enough for today, I think. That's plenty. We've done a bit. Let me know if any.